Today is a big day because even though I was making you do that limit as h approaches 0 and it was a really, really long way, and it made you probably gain a few friends and a little bit more popular than what you were the previous day, there's an easier way, and we're going to do it right now. So there's lots of different ways that we're going to do this, and you're going to spend lots of time figuring out how to find derivatives, but we are not actually going to use the limit as h approaches 0 of f of x plus h minus f of x over h over and over and over again. Thank goodness, because that is very, very long. Okay, so in this one it says analytically finding the derivative of polynomial type sine and cosine functions. For right now, we're just going to start with the polynomial and polynomial type. And so in this one it says consider the function f of x equals 3. What does the graph of this function look like? Okay, so let's just do this. Here's my coordinate grid, and I've got f of x is equal to 3. So I go up 3, and it always means that y is stuck at 3. If the tangent line were drawn to f of x at any value, so if I found the slope at any value, the slope of the tangent line, what would the slope of that tangent line be? Are you thinking? Maybe now? Hey, the slope's 0. Do you see how the rise over run, I would just get 0 over and over and over again? This is the case if I would have said anything. So f of x equals 3, 7, 29, 42 and a half, negative 512. The slope would always be 0 of any just y equal to some number. So if you say c is any constant, the derivative or the slope of the tangent is 0. Okay, so here's some other ones. So I'm going to find this derivative and I'm going to say, it's kind of like a puzzle. We can play this game. And you're like, I'm going to say, instead of doing this the really long way before, if I just look at this, I'm going to go, what is this derivative? And I'm just going to get 6x minus 2. Does anyone know how I perform that magic? I'm going to do one more and then I'll give you a hint. Okay, in the next one, the derivative, even though there was a really long way to do this, whereas f of x plus h minus f of x over h, I can tell you magically in my brain right now that this derivative is going to be negative 15x squared plus 4x minus 3. What? Am I a math magician? Okay, maybe not. So you think of it. How do you think that I'm doing this? Okay, I'm going to show you for real. Okay, f prime of x, because, you know, it's not fun to make math a guessing game, but I do like puzzles a little bit. Not all the time. I have to be in the right mood. The derivative of any constant, so like here and here, we said was 0. So I didn't even have to worry about those. So the derivative of that would just be 0 also. In all the other ones, what I'm doing is I'm taking the exponent and I'm multiplying it by the coefficient. So I would get 3 times negative 3, and I get negative 9x. And then I reduce this exponent by 1. So if you can see up here, I took 3 times negative 5 and I got negative 15, and then you subtract 1 off the exponent. And you might say here, well, did you do that same thing? 1 times negative 3 is negative 3. This would be like x to the 0 power. Anything raised to the 0 power is 1. 1 times negative 3 is negative 3. But in this one, you could also say, well, what's the slope of a line, negative 3x? And the slope of that line would just be negative 3. So you could do it either way. Okay, so I got negative 9x squared. 4 times 6 be 24x. Subtract the exponents by 1. Okay, so the next one, you're like, yeah, that's great, but now I've got negative exponents. It's okay. This one is finding the derivative of polynomial type. Technically, a polynomial is any function that has positive integer exponents, but we can use this one to do, or this rule, it's called the power rule, to find the derivative of anything that looks kind of like a polynomial. So you've got a variable times a coefficient, and we've got some exponent on the variable. We can do this way. So in this one, I'm going to say f prime of x is equal to, I take the exponent of negative 1 times negative 2, and I get 2x. Subtract 1 from the exponent. So I've got negative 1 minus 1 is negative 2. Negative 2 times 3, I jumped ahead, I would have gotten negative 6x. Subtract 1 from this exponent, and I get negative 3. And then what I want you to do is go one step further and immediately rewrite this so that it's not confusing what I do with negative exponents. So with the negative exponent, all it means is that it changes the position in this function. So if I have an x to the negative second power, I'm really dividing by x to the positive second power. Minus 6 over, this would be dividing by x to the third power. I would rewrite this right away so that it's easier to use from here on out. Don't rewrite it at the very beginning because then the power rule doesn't apply. Okay, this one, there's our fractional exponent. What do I do here? Same business. I take 2/3 times 6. 2/3 times 6 would be 6 times 2 is 12, divided by 3 is 4. And then I'm still going to do 2/3 and subtract 1 off of that. 1 is also known as 3/3. 2 minus 1, or 2 minus 3 is negative 1. Keep the common denominator. Negative 2 times 4 would be negative 8x. Subtract 1 off the exponent. And I would rewrite this right away. So I would say 4x. You could say to the 1/3 power, or you could say the cubed root of x. It means the same thing. This is always saying what power I'm taking x to. This is what root. So this is the third root of x minus 8 over x to the third power. So get in the habit of rewriting this. Okay, this one, negative 1/2 times negative 6. And be careful, make sure you're labeling every time this is a f prime of x. Negative 1/2 times negative 6 would be positive 3. Negative 1/2 minus 1 is going to be negative 3/2 plus 3 over 2x to the negative 1/2, because I took 3 times 1/2. And then I subtracted 1 from the exponent. So this is going to be 3 over x to the 3/2 plus 3 over 2x to the 1/2. So anytime you have something like this, and this means the derivative with respect to x. I know that's the first time that you've seen that, but it's just saying, what is the derivative? There were two different people, Newton and Isaac Newton and Gottfried Leibniz. They came up with calculus at the same time. They were both responding to a same prompt that was talking about a ball rolling down a hill and when is it going to be at its fastest point, like when would it be the steepest. And they both were responding to this, but they came up with calculus in two different parts of the world at the same time, which is nuts. But we take notation from both of them. So this means this is the Leibniz notation. The f prime is the Newton notation. But the derivative of any function that looks like this would be, I take n, because I'm multiplying it by whatever's in front, so by the coefficient, times x to the n minus 1. Okay, let's keep going on. So the hardest part of this is actually probably the algebra, but we're gonna work through these together and you're just gonna skip through to the parts that you need and I'm gonna help you on those parts. So in this one, it says, in order to apply the power rule for differentiation, differentiation just means finding the derivative. So finding the slope of the tangent. The power rule is if I have an exponent, and that's, I take the exponent times the coefficient, and I subtract 1 and do that rule, that's the power rule. If I write in polynomial form, I need some number times a variable raised to some exponent. It doesn't have to be, so here, coefficient times an x raised to some exponent. It doesn't have to be an official polynomial where the exponents are all integers. Or not even integers. They would have to be like integers greater than or equal to 0. Anyway, it doesn't matter. Anything that looks like a coefficient times x raised to an exponent, we're good. We can use the power rule. So if you look here and you're like, that doesn't look like one. This doesn't look like one. None of these really look like it except for this one. The one on the bottom. I can do this one right away. That's good. I can find f prime of x and say the exponent, so 3/4 times negative 4 would be negative 3. Subtract 1 from the exponent, that would be negative 1/4. Plus 2 times 1/4 would be 2/4, also known as 1/2. 1/4 minus 1 would be negative 3/4. And we're going to get back to rewriting this in a second. But in these ones, that's the only one that I could actually do f prime right away. All the rest of these are kind of messed up and I need to do some work first. This is where your labels are going to be really, really important. I'm going to say f of x, and I'm going to rewrite this first using stuff from algebra that probably didn't even know that I remembered, or you didn't know you remember, but now you're going to. 2 over x squared, instead of keeping it like that, you need to rewrite this as 2 times x to the negative second power minus 4x to the third. So notice my label is f of x. So now I know, hey, now I can take the derivative. I get negative 4x to the negative third power minus 12x squared. So in all of these, what I want you to do is try to go through and simplify, or I'm sorry, and like, well, you could say simplify, change this into a polynomial form. Once you do that, it says leave your answers with no negative or rational exponents and as single functions. If this were on a free response question and you left it like this, I'd say, sure, you're good. But on many, many multiple choice questions, your answers will not be written like this. So you have to know that f prime of x can be rewritten as negative 4 over x to the third minus 12x squared. What's also hard, and this one I would say is totally acceptable, and if you're not talking about multiple choice, keep it exactly like that because you don't want to do more work and mess it up. But on some questions, your solution choices, the only things in front of you, are going to have a single fraction. So in order to make this look like it has a common denominator with this, I would need an x to the third over here. And the way I do that, I can't just put that in all willy-nilly. I need to multiply by some weird form of 1. So x to the third over x to the third. Now I can say that this is f prime of x is equal to negative 4 minus 12x to the fifth over x to the third. And then this is your final answer. If you left it like this one without the red, totally fine. And if that's where you're at right now, do that. Okay, so try the other ones and stop the video as needed. And go to the parts that you need. I'm going to do this one first, then this, and then this one. So you can do it also. Sorry, you probably couldn't see. So this. Okay, I'm going to do that. Come back to me when you get a chance, and you try it too. Okay, so to talk through this, just in case you came back to this part and needed this one, f of x, in all of these, I could divide by x. And so what I'm going to do is I'm going to factor out an x from the numerator. And I have 3x to the third minus 3x minus 2. And if I do that, I can see the x just goes away. And I have 3x to the third minus 3x minus 2. And this is all pretty nice, like immediately. If I do it in this problem, you see how there's x to the third, 5x squared, and x to the fifth. There's more in the denominator. So you can't do it like this one. So what I would recommend in a problem like that one is x to the third over x to the fifth, 5x squared over x to the fifth. Okay, I just told you I was going to go in order and then I skipped, so I'll come back to this one in a second. Okay, I wrote this was f of x. If you don't label, you might be tempted to think that that's your final answer, and it's not yet. You have to actually find the derivative. So 3 times 3 is 9, x squared minus 3. This one is all sorts of gross. I'm going to use a different color because I can. But you actually have to just expand this first. So I'm going to take x plus 3 times x plus 2. And I would get x squared plus 2x plus 3x would be plus 5x plus 6. And I need to multiply that by 2x plus 1. And so I'm going to say f of x is equal to 2x cubed plus x squared, because I took it here, plus 10x squared plus 5x, because I did this, plus 12x plus 6. That means if I simplify this, I would get 2x cubed plus 11x squared plus 17x plus 6. All this work, and you notice it's f of x, f of x, f of x. I haven't done any calculus yet until right now. And I get f prime of x is equal to 6x squared plus 22x plus 17. Okay, in the next one, I said it, just to explain this real quick again, because I said I would do it in this order, and if you're just getting to this part of the video, this one can't be like the one up here where I just factor out an x, because the exponent in the denominator is higher, the degree in the denominator is higher than the degree in the numerator. So what I'm going to do here is I'm going to simplify this and say, you know what, if I know I can add with a common denominator, I can also take a common denominator and just put it over every term. So if I redid this, I would say, well, x to the third over x to the fifth would be the same as 1 over x squared, or I could subtract my exponents and I could say that's the same thing as x to the negative second power. Over here, same idea, this would be 5x to the negative third power, because I would have 3 x's left over in the denominator. Now I can take the derivative, and I would say negative 2x, subtract 1 from my exponent, so I have negative 3, negative 15x to the negative fourth power. So this would be, if I rewrote this, negative 2x to the third minus 15 over x to the fourth. You could definitely keep it like that, and I would suggest keeping it like that unless you didn't see that answer choice. And so then you would have to say, well, I need a common denominator. This has x to the third, this has x to the fourth. So I can multiply this first one so that this is the same thing as x to the fourth now. And I would have negative 2x minus 15 over x to the fourth. This is the same thing as this, which is the same thing as that. Okay, one more. This one looks disgusting, but it's not that bad. So we're going to do it together. Well, maybe you did it on your own and you just want to check your work. This is the same thing as writing 3x, and then this is x to the second power, but it's the cubed root. So we say 2/3. This one is actually already set up nicely. We just have to remember that if I have a common base, so this the same base, x here and x here, I can subtract my exponents. So this is still f of x. Make sure you label. I would have 3x, 1 minus 2/3. It's going to be 1/3. You take the derivative, f prime of x is equal to 1/3 times 3, which is just 1. X, subtract 1 from my exponent. 1/3 minus 1 would be negative 2/3. That means this would be 1 over x to the 2/3. Or if you wanted to rewrite it, you could say this would be x to the second power, and then the cubed root of that. I probably would keep it in that form once I got there. Okay, last problem on this page. I already started it. We said f prime of x. The only thing that I'm going to do with this is that I'm going to rewrite it. F prime of x is equal to negative 3 over x to the 1/4 power plus 1 over 2 x to the 3/4 power. This one's kind of weird, the way that you would put this together, because if you wanted a common denominator, I'm going to actually write it below because I think it's almost easier to keep it like this. But I could say negative 3 over x to the 1/4 power plus 1 over 2 x to the 3/4 power. And in order to get this to be x to the 3/4 also, and have a 2 in it, I would have to multiply by 2x to the 2/4, also known as 1/2. And then I would get negative 6 x to the 1/2 power plus 1, because of this over here, over 2x to the 3/4 power. Ew. That does not look nicer than that to me, so I definitely just say, hey, this is my answer. But I wanted to show you just in case. I think you would see it much more likely as that. I don't know why I went through that one part, but whatever. That's what we did. Okay, you did it. If you need to stretch, about stretching, do that. I think you're awesome. I'm super proud of you, for real. You're learning calculus right now, and it makes me really happy that you are putting in the effort. So whoever said kids these days don't know these kids, because you are swell, and I'm super thankful to be your teacher. Okay, bye.